And good morning, everybody. It is May 27th. We're almost there. We really only have, check it out. Here's my calendar, okay? Look at this. 1, 2, 3, 4, 5, 6, 7, 8. 8 academic days, because these last few days is just going to be me making sure everybody's got things in. So we won't have a final. This last week, if you are done and you got an A, then you're done, right? But for the rest of you, if you're behind, I'm going to bug you to get stuff in, okay? And then we're done, okay? So we're getting close. Figure out 8 academic days left. That's it. We can do this. I know we can. So, first of all, if you have not finished Chapter 8 test, please get that done and into me. You don't want that to go as an incomplete. Please get that done. I want to get caught up before the end of the year, okay? Last night's homework, let's take a look at that real quickly. On Pythagoras' theorem, which should have been really easy because Pythagoras' theorem is something everybody knows how to do. If I look at the answers, here we are. Number 1, x is 135, which makes it a perfect triple. If all 3 numbers are whole numbers, it's a perfect triple. It doesn't happen that often. There are not that many of them. Number 2 is 6.9, so that's not a perfect triple, okay? 3 is 25. So yes, it's a perfect triple. In fact, it's 3, 4, 5, just inflated. 4, 11.7, no, that's not a perfect triple. 5, 53.9, no, it's not a perfect triple. 6, 102, yes, so it is a perfect triple because all 3 sides are whole numbers. 7 is about 0.4 miles is how far you've biked. 8 turns out to be a right triangle because 90 squared plus 216 squared does equal 234 squared. 9, it's an obtuse triangle because 1 squared is 1, 1 plus 1 is less than 3, okay? That's the homework. Make sure you get it to me, okay? Now today's lesson deals with what we call special right triangles. First thing I'm going to do is take a look at our journal, okay? So there are 2 what we consider special right triangles. I'm going to show you these 2, okay? So the first one is called a 45, 45, 90 triangle. Well, think about this. If you take a square, all sides are equal. And if you cut it in half, you make a triangle. Remember, all sides are equal. So these 2 sides are equal. Well, it turns out by Pythagoras' theorem, this side would be some square root of 2. Okay, so if there's 1, that's be the square root of 2. So it always works that way if it's a 45 degree, 90 triangle. Only works on a 45, 45. So let's check this out. So let's say this one's 5, 5. Makes sense. Half square, half a square, 5, 5. Well, this side turns out to be 5 square roots of 2. Now, if you want a decimal answer, you can get a decimal answer here. You just go, what is 5 square roots of 2? Or you get about 7.07, okay? So they show the formula. Whatever these 2 sides are, 5 square roots of 2, maybe 10 square roots of 2, maybe 7 square roots of 2, half a square, so that length or the hypotenuse is always whatever these are times the square root of 2. It's that simple. Now the other special right triangle is what we call the 30, 60, 90, where the angles are at 30 degrees, 60, and 90 degrees, okay? Well, it turns out that the hypotenuse is always twice this, see? So you've got x and you got 2x. In fact, I would probably draw it more like this. X, 2x. So this hypotenuse is always twice this short leg. So if this is 5, this would be 10. Twice as big. Always on a 30, 60, 90 triangle. Now the longer leg is whatever this is times the square root of 3. So this is going to be 5 square roots of 3. Okay? Whatever the 5 square roots of 3 is a decimal. You can check it out. 5 square roots of 3. And it's about 8.66 for that side. But it's so much easier just to put the numbers down than to use Pythagoras' theorem. Okay? Here's my other example. Okay, here's the hypotenuse. So it's twice as big as the short side. So if this is 12, this has to be 6. And this leg here is whatever this is times the square root of 3. Whatever this is, which makes this 6 square roots of 3. Okay? So these are our 2 special right triangles. We've got our 45, 45, x square roots of 2. And we've got our 30, 60, 90 triangle. We have x, short leg, 2x, the hypotenuse, and x square roots of 3, the long leg. And same thing here, okay? These are the same triangles, just one is on its side and the other one's standing up, okay? So now let's look at my notes. So my notes are going to be going through that. So again, 45, 45, 90 triangle. Looks like this. I'm just going to draw it in by hand. It's not going to be perfect, but it's going to be pretty darn good. If it is a 45, 45, 90 triangle, it's half a square, right? It's half a square. So that means these two sides have to be equal because I cut a square in half. The hypotenuse is going to be, whatever these two are, x times the square root of 2. The square root of 2 is approximately 1.41, if you're curious. So, example 1. Here it is, 45, 90. Well, this has to be 45. It has to also be 45 degrees. So 8, half a square, 8, and, well, yeah, probably 8. 8, this side's going to be 8. And the longer, the hypotenuse is going to be just whatever this is, times the square root of 2. 8 square root of 2. Okay, that's all we need to do. Okay, we could leave it as 8 square root of 2, or we could find out what the decimal happens to be, okay? Number 2. Okay, find x and y. Well, this one's different because the 18 square root of 2 is sitting right where it should be. So that means that x, the value of x has to be 18. So that means this side's got to be 18, and this side's got to be 18, okay? I should say x and y. I guess I need to fix that someday. X and y, okay? I knew it was 45, 45 because I said those two sides are equal, okay? 18 square root of 2, 18, 18, okay? Because it has to be 45, 45 because those two sides are equal. It's got to be half a square. Okay, now example 3 is a little bit different, okay? Because right here, this is supposed to be some x squared root of 2. It's not. It's 12. What I want to do is find what x is. So think about this. 12 is supposed to be equal to some x squared root of 2. So let's set it equal. 12 is equal to x squared root of 2. Well, let's solve for x. Well, that's easy to do, to solve for x. I'm going to divide by the square root of 2, divide by the square root of 2. So I get 12 divided by the square root of 2. That's an okay answer, but not a great answer. So if you go back many months, we had a rule. It said you couldn't have a square root in the bottom. So we fix the problem with the problem. Square root of 2, square root of 2. Or we just divide the 2 into the 12, and we wind up with 6 square root of 2. Okay? That's a better answer. 6 square root of 2, 6 square root of 2 for both of these. 6 square root of 2. Remember, it's half a square. 6 square root of 2. Okay? Alright. Turn the page. Isn't this easy? Hopefully. Alright. Draw the 30, 60, 90 triangle. Okay, so I can draw it in two different ways. One, I can draw it on its side. And it's special. These angles have to be 30 degrees, 6 degrees, and 90. It has to be the special right triangle. This shorter side we'll call x, and the hypotenuse is always twice as long as this. Twice as long. So we're going to call that 2x. This other leg is whatever this is, times the square root of 3. Square root of 3. X square root of 3, okay? Or we could draw the exact same triangle just standing on its end. Take this triangle and turn it up on its end. This would be x. 60, 30, 90. This side is the short side, so this hypotenuse is the double that, 2x, and the longer leg is always whatever this is times the square root of 3. Okay, how does that help? Well, it helps with, I don't have to do Pythagoras theorem. So let's look at example 4. Here's the 12. So the 12 is sitting right where the 2x is. See? The 12 is sitting where the 2x is. So the 12 is twice as big as this side, so this side has to be 6. Okay? Now, this 6, how do I find the longer leg? Well, the longer leg is whatever this is times the square root of 3. Okay? Whatever this is times the square root of 3, so this would just simply be 6 times the square root of 3. Okay? Easy. Or you could use Pythagoras theorem, but gosh, this is so much easier, okay? 5, okay, 18 is sitting right here. 18 is sitting where the longer side is. So the 18 is twice as big as this side. So if the 18 is twice as big as the short leg, then this side's got to be 9, okay? And the hypotenuse, the longer leg is whatever this side is times the square root of 3, okay? So this is going to be just simply a 9 square root of 3. Okay, this should be pretty simple. We use this all the time in other math classes, and actually you'll see this used actually in the real world. The real world. like this is not the real world. Sometimes it just doesn't seem like it. Okay, let's take a look at example 6. 10, 10, 10. It's equilateral, right? So if this is equilateral, 10, 10, 10, then these three angles are also equal. Well, 180 degrees, right, for a full angle. All three of these angles are equal. So that means this is going to be 60, 60, 60. Okay, that doesn't help much, but we're getting there. So to find the area of a triangle, what do we know about the area of a triangle? Well, the area of a triangle is 1/2 its base, well, that's 10, times its height. I don't know the height. In fact, let me draw it in. Here's the height of the triangle, but I don't know what it is. However, what I just did is I broke the triangle into two different triangles, and the triangle that I want to look at is this one here, okay? Let's just look at this one here, okay? Two completely equal triangles, okay? So let's take a look at this triangle. Let me redraw it over here. Okay, again, my goal is to find the area. To find the area, I need to find this height, okay? So, I broke the triangle into half, okay? And when I broke it into half, this is 60, right? This is 5, right? Broke it in half. And then this is still 10. Okay, so here's my triangle. The only thing I don't know is the height. Now, if I look back up here, okay, I've got my 5, I've got my 10, and right here for this side is going to be 5 square roots of 3. So the height of this triangle is 5 square roots of 3. Okay, so let's put that in. 5 square roots of 3 is the height of the triangle. Okay, so now we can finish this up. I want the area of this triangle. Area of a triangle is 1/2 its base, which is 10, times its height, which is 5 square roots of 3. Okay. If we want to leave the area in terms of square roots, half of 10 is 5. 5 times 5 is 25 square roots of 3 centimeters squared. Or if we want a decimal answer, which is fine too, we can just use our calculator. And we can just put it in our calculator and go, okay, I can go 1/2 0.5 times 10 times 5 times the square root of 3, and I'll get a decimal answer, which is about 43.3. Either answer is fine. 43.3 centimeters squared. I kind of like this one because it's exact, but either way. Okay, so that's what I have for you today. Homework, which is pretty darn easy, is really easy. On page 288, 1 through 7 all. Let's take a look at that real quickly. Okay, 288. There it is. Page 288. Make sure I write this down. Okay, page 288. We're going to do 1 through 7 all. Simple, simple, simple. Okay, and that's all I have for you. And we'll talk tomorrow.